PFAS stands for per- and polyfluoroalkyl substances. They are a large group of man-made chemicals. These chemicals are known for their strength and durability. PFAS are resistant to heat, water, and oil. This makes them useful in many products. However, these same properties also make them a health concern. PFAS don't break down easily in the environment. They can persist for a very long time. This is why they are often called forever chemicals. PFAS are made up of a chain of carbon and fluorine atoms. The bond between carbon and fluorine is incredibly strong. This strong bond is what gives PFAS their unique properties. However, it also makes them difficult to break down. This means they can linger in the environment and our bodies for years. The widespread use of PFAS started in the mid-20th century. Their unique properties made them ideal for various applications. Their ability to resist water and oil made them perfect for non-stick cookware. Their durability made them suitable for firefighting foams. However, the long-term consequences of their use were not fully understood at the time. PFAS were first created in a laboratory in the 1930s. Their usefulness was quickly recognized. Companies began to manufacture PFAS for a variety of products. One of the first major uses of PFAS was in non-stick cookware. Teflon, a brand name for a type of PFAS, revolutionized cooking. Food wouldn't stick to the pan, making cooking and cleaning easier. The applications of PFAS extended beyond the kitchen. They were used in firefighting foams for their effectiveness in extinguishing oil fires. These foams were widely used at airports and military bases. PFAS also found their way into textiles and carpets for their stain-resistant properties. The production and use of PFAS increased significantly over the following decades. They became a part of everyday life. However, concerns about their potential health and environmental effects started to emerge. Scientists began to detect PFAS in water sources and wildlife. This raised alarm bells about their persistence and potential for bioaccumulation. PFAS are commonly found in food packaging materials. These chemicals help prevent grease and oil from soaking through. This is especially important for fast food containers and microwave popcorn bags. PFAS ensure that your food doesn't leak through the packaging. Consider the last time you ordered a burger and fries. The paper wrapping the burger likely contained PFAS. This helps keep the grease from staining your hands. Similarly, the inside of microwave popcorn bags is coated with PFAS to prevent oil from seeping through. PFAS are also used in some types of cookware. Non-stick pans often have a PFAS coating. This coating makes it easier to cook without food sticking. However, when heated to high temperatures, PFAS can leach from these pans into your food. PFAS can migrate from packaging and cookware into our food. This means we can ingest these chemicals without even realizing it. While more research is needed to fully understand the health effects of PFAS, studies have shown potential links to several health problems. Exposure to certain types of PFAS has been linked to liver cancer. Studies have shown a higher incidence of liver cancer in individuals with high levels of PFAS in their bodies. While more research is needed to establish a definitive cause and effect relationship, the findings are concerning. PFAS have also been associated with immune deficiency. The immune system is our body's defense mechanism against infections and diseases. Exposure to PFAS can weaken the immune system, making individuals more susceptible to illnesses. Another concern is the potential impact of PFAS on childhood development. Studies have shown that children exposed to high levels of PFAS may experience developmental delays. These delays can affect their cognitive abilities, motor skills, and behavior. Section 5, PFAS and the environment. A growing concern. PFAS don't just pose a risk to human health, they also have a significant impact on the environment. Their persistence means they can contaminate water sources, soil, and air. When PFAS are released into the environment, They can contaminate water sources. These chemicals can seep into groundwater and rivers, affecting both drinking water and aquatic life. PFAS have been detected in drinking water supplies across the United States and other parts of the world. PFAS can also accumulate in soil. This is a concern for agriculture as PFAS can be absorbed by crops. When these crops are consumed, they introduce PFAS into the food chain, potentially harming both animals and humans. The widespread use of PFAS has led to their presence in the air we breathe. While the levels are generally low, they can be higher in areas near industrial facilities that produce or use PFAS. Section 6. The body burden, how PFAS accumulate in humans. PFAS are often referred to as forever chemicals because they don't break down easily in the environment or in our bodies. Once they enter our system, they can stay there for a long time, accumulating over time. We can be exposed to PFAS through various pathways. Consuming contaminated food and water is a major route of exposure. We can also inhale PFAS present in the air or absorb them through our skin. Once PFAS enter our bloodstream, they tend to bind to proteins in the blood. This makes it difficult for our bodies to eliminate them efficiently. As a result, PFAS can build up in our organs, including the liver, kidneys, and even the brain. This accumulation of PFAS in our bodies is known as the body burden. The higher the body burden, the greater the potential risk of health problems associated with PFAS exposure. Section 7. Taking action. Regulatory measures to combat PFAS. Recognizing the potential threats posed by PFAS, regulatory agencies around the world have started taking action to limit their production, use, and release into the environment. The United States Environmental Protection Agency, or EPA, has been at the forefront of PFAS regulation. In recent years, the EPA has set drinking water health advisories for certain types of PFAS, providing guidance on safe levels of these chemicals in drinking water. The EPA has also taken steps to phase out the production and use of certain PFAS. These actions are aimed at reducing the overall presence of PFAS in the environment and minimizing human exposure. In addition to federal regulations, several states have implemented their own measures to address PFAS contamination. These measures include setting stricter drinking water standards, banning the use of PFAS in food packaging, and requiring manufacturers to disclose the presence of PFAS in their products. Section 8. Protecting yourself, making informed choices. While regulatory efforts are underway to address PFAS contamination, there are steps you can take to minimize your exposure and protect yourself and your family. One of the most effective ways to reduce your PFAS exposure is to choose PFAS-free products whenever possible. Look for products that are labeled as PFAS-free or made without PFAS. This applies to food packaging, cookware, clothing, and other household items. When cooking, opt for cookware that is made without PFAS-based non-stick coatings. Cast iron, stainless steel, and ceramic cookware are good alternatives. If you do use non-stick cookware, avoid overheating it, as this can increase the risk of PFAS leaching into your food. Another way to reduce your exposure is to filter your drinking water. While not all water filters remove PFAS, some are specifically designed to do so. Look for water filters that are certified to remove PFAS. Section 9. The future of food safety towards PFAS-free solutions. The issue of PFAS contamination highlights the importance of food safety and the need for continuous innovation to develop safer alternatives. Researchers are actively working on developing new materials and technologies that can replace PFAS in food packaging and other applications. One promising area of research is the development of bio-based materials. These materials are derived from renewable resources such as plants, which makes them more sustainable and less harmful to the environment. Some bio-based materials have shown promising properties as potential replacements for PFAS in food packaging. Another area of focus is the development of advanced manufacturing techniques that can create water and grease-resistant coatings without the use of PFAS. These techniques include plasma coating and atomic layer deposition, which can create thin, durable coatings with enhanced barrier properties. The transition to a PFAS-free future will require a collaborative effort from governments, industries, researchers, and consumers. By working together, we can create a safer and healthier food system for ourselves and future generations.